In the previous video, we looked at solving this differential equation 7 dy by dt plus 49y equals 28. And we used the integrating factor method. And we have an initial condition of y of 0 is equal to 1. The result we got was y equals 4 over 7 plus c over e to the 7t. And when we found the initial condition, we got y equals 4 divided by 7 plus 3 divided by 7e to the 7t. Now let us solve it again, this time using the Laplace transform. Alright? Now, we can surely get smaller numbers if we divide through by 7. So, let's divide by 7 just to get smaller numbers. You could use the Laplace transform on it just the same, but I see the benefit of dividing by 7. So we have dy by dt plus 7y is equal to 4. Alright, good. Now, the next step is to find the Laplace transform of each term. Didn't bother to write out the full word Laplace transform. I just use the curly L as is customary for the Laplace transform, right? So in this case, we need to find the Laplace transform of dy by dt equals whatever it is. We need the Laplace transform of 7y, which would be, well, we won't find a y in the Laplace transform table. This would turn out to be 7 Laplace transform of f of t. That's what we will see instead of y equal. Alright? Remember, the Laplace transform of 7 times a function is the same as 7 times the Laplace transform of the function. So I put the 7 on the left hand side of the Laplace transform on the right of 7. And then we're going to need the Laplace transform of 4. We want to find out what is the Laplace transform of 4. Alright? So, let's look at our Laplace transform tables. Alright. So we need the Laplace transform of the derivative. Okay. The Laplace transform of the first derivative is s, big F of s minus f of 0. So it's s f of s minus f of 0. So it is s f of s minus f of 0, small f of 0. Alright? Now the Laplace transform of this one is 7 times the Laplace transform of f of t. What is it? The Laplace transform of y. This is saying of f of at. Alright? This table puts it in a more complicated way as 1 over a f of s divided by a. Now, here, let's look at this other table and see how they put it. Laplace transform of, oh, it's the top I should look at, you know, as the top part I should be looking at. Well, I would look at it like that. It's up the top. Right. It's the Laplace transform of f of t. It's called f of s. Let me see the other table. How they put it. What they have here. Right, when you find the Laplace transform of f of t, you get f of s. So it's big F of s. The the f of s. Let me put it in a different color, because that's what we're going to transpose for later on, f of s. So let's put it f of s. Alright, so now this is 7 big f of s, right? So that's f of s. Now what's the Laplace transform of 4? In this case, our table will give us the Laplace transform of a number. Well, here, this table shows it in a more complicated way. Instead of showing a number, it's showing delta t. So let's see what this table says. Right, simple. Just show 1. The Laplace transform of 1 is 1 over s. Nice. So the Laplace transform of a number, if you consider the number times 1, is just the number times 1 over s, which would be the number over s. So in this case, Laplace transform of 7 would be 7 over s. Alright. So let's put them together. What we have, Laplace transform of dy by dt. What we have is s, big F of s, minus f of 0, whatever that will be, then plus, then we have plus, this will be 7 f of s, this big F of s, right? I want everything else in green and the f of s alone in white. And then equals 4. That's equal 7 over s. Right? So this is what we have. Okay. Now let's transpose to make f of s the subject. So we have f of s plus 7 f of s equals 7 over s plus f of 0. Alright. See the transposition there? Then we factor out f of s. F of s outside the bracket. Inside the bracket we have s. We have s plus 7 equals 7 over s plus f of 0. Alright. We divide both sides by 7 plus by s plus 7. We have f of s equal 7 over s plus 7 plus f of 0 over s plus 7. Okay. Now, let's see something here. We have to write this part in partial fractions, you know. So, let's deal with that. We have 7 over s plus 7 equals a over s plus b over s plus 7. If you multiply both sides by s plus 7, right? So remember what we're dealing with here is partial fractions. Oh boy, let me rewrite this. Partial fractions for that part. Alright. So if we multiply both sides by s plus 7, we have 7 equal a s plus 7 plus b times s. Now let s be negative 7, what we would have, if s is negative 7, we would have 7 is equal to, this part would go to 0, because negative 7 plus 7 is 0, equal negative 7b. So b would be 7 over negative 7, which is negative 1. Let s equal 0. What would that now? We'd have 7 equal 0 plus 7 is 7. 7a plus 0. This would be 0. 0 times b would be 0. So a is equal to 1. Alright. So in this case, a is equal to 1. Now, if we have this, then our f of s would be equal to, in this case now, a, which is 1 over s plus negative 1, which is minus 1 over s plus 7 plus f of 0 over s plus 7 plus f of 0 over s plus 7. Alright, so that's what we have there. Now, we can find the inverse Laplace transform now. So, the inverse Laplace of f of s is equal to the inverse Laplace of 1 over s minus the inverse Laplace of 1 over s plus 7 plus the inverse Laplace of f of 0 over s plus 7. Alright, inverse. So let's find the inverse Laplace transform of each side. So the inverse Laplace transform of f of s, what is that? Well, if we find the inverse Laplace transform of f of s, now remember, when you're going from right to left, no, from left to right, you're finding the Laplace transform. But when you're going from right to left, you find the inverse Laplace transform. The inverse Laplace of f of s is f of t. In this case, we call our f of t y. So on this side, you get y equals. Now, what's the inverse Laplace of 1 over s? Let's see. The inverse Laplace of 1 over s is 1. Right? So the inverse Laplace of 1 over s is 1 minus, what's the inverse Laplace transform of 1 over s plus 7? Let's see something here. Here we have 1 over s minus a. The inverse Laplace transform of 1 over s minus a is e to the positive at. The sign of the negative a changes to positive. So, if we had 1 over s plus a, it would be e to the negative at, because its sign would be changed from positive to negative, right? So, let's apply that principle over here. 1 over s minus a, 1 over, what we have is 1 over s plus 7. Is e to the something t. Is going to be e to the something t. What t? In this case, we say negative a is minus a. We have positive a times t. So we have plus 7. This would be negative 7t. Alright? So that's what we have there. And then plus the inverse Laplace of f of 0 over s plus 7. F of 0 is going to be just a constant, right? So going to be f of 0 e to the negative 7t. All right, so that's what we'd have. We run out of scrolling space. We can't scroll down anymore. So let's draw a line here and continue working on the right. All right, so here y equals 1 minus, let's rewrite this. All right, instead of rewriting it, let me just copy it. Combine this one and move it over. All right. Good. I'm doing less work here. Saving ink. Well, it's not really ink, but at least I'm saving energy by not having to rewrite all of this. Anyway, so this is y equal. So you have 1. You could write this as plus e to the negative 7t open bracket f of 0 minus 1. All right. So that's what we have as the general solution, right? Oh, this had said 4 over 7. How did we get the 4 over 7 again? All right, let's review. Let's review and make sure. So we have this f of 0, f of 4. Laplace transform. Oh my, I made a mistake here, you know. For the Laplace transform of 4, I put 7 over s. It should be 4 over s. My, 4 over s. Right? It should be 4 over s. That was my mistake. Oh boy. So for this part, for the Laplace transform of 4 is 4 over s. So what we really have is s, f of s minus f of 0 plus, this was 7 f of s equals 4 over s. So this was 4 over s. And then when we transpose s, f of s equal f of 0, this was 4 over s. And then this also 4 over s, right? So here, this was 4 over s plus 7. Then when we multiplied out everything, right? When we multiplied out everything, what we would get is 4 times. So this would be 4 times and then equal, 4 equal. Then we make s equal negative 7. This would have been 4 equal all of this. So b would be 4 over negative 7. So negative 4 over 7. And then this would be saying 4 equal 7a. When we work it out, we get 7a. So a would be positive 4 over 7. So what we would have is a, which is 4 over 7s. So that would be 4 over 7 divided by s minus 1 over, but here, which this would have been b, 4 over 7. So this would have been 4 over 7 divided by this plus f of 0, right? Over s plus 7. So when we found the Laplace transform inverse, what we really would find is the Laplace inverse of 4 over 7 over s, 4 over 7 over s minus 7. So this would have been 4 over 7 e to the negative 7s minus, and then this part, well, 4 over 7. This would have been 4 over 7 times, no, minus 4 over 7 e to the negative 7s plus f of 0. So when we come up here, y equal 4 over 7 minus 4 over 7. So this should be y equal 4 over 7 minus this 4 over 7 e. So this would be 4 over 7 plus 4 over 7 e to the dot. And then what we would have is open bracket. So e to the negative s outside the bracket. This would have been, would have to redo the factorization part again. So it would have been e to the negative 7t open bracket f of 0 minus 4 over 7, right? So that's what we should have. So this would be 4 over 7, 4 over 7 plus e to the negative 7 c. The c part would be this, alright, over e to the 7t. So we can rewrite this as y equal 4 over 7 plus f of 0 minus 4 over 7 divided by e to the 7t. Then the initial conditions, we said y of 0 was 1. So that means when x equals 0, y equals 1. So 1 equals 4 over 7 plus f of 0 is 1, 1 minus 4 over 7 over, oh, yeah, f of 0, right, over e to the, I should write when t equals 0, right? When t equals 0, y equals 1. So y is 1 equal 4 over 7 plus f of 0, no, f of 0 is 1 minus 4 over 7 over e to the 7t, but t is 0, right? Or f of 0, my mistake, f of 0 is what we want to find, we want to find f of 0. What is f of 0? Now, here, we can subtract the 4 over 7 from both sides. 1 minus 4 over 7 equals, this would amount to 1, the f of 0 minus 4 over 7, right? So, here, notice if we add 4 over 7 to both sides, we have f of 0 is equal to 1, right? So f of 0 is 1, so we say y equals, alright, let's write it down here, y equals 4 over 7 plus, so y equals 4 over 7 plus f of 0, which is 1 minus 4 over 7 plus 1 minus 4 over 7 divided by e to the 7t. E to the 7t. What is 1 minus 4 over 7? Is 1 over 1 minus 4 over 7. Same as 7 over 7 minus 4 over 7. 7 minus 4 is 3. So it's 3 over 7. So the top part here works out to be 3 over 7. Which you can write as 3 over 7 e to the 7t. Which is the same thing here as 4 over 7 plus 3 over 7 e to the 7t, right? Alright, so that's it for this video. I'm going to review this video, but I'll do that in another video. So I'll see you then.